All right, for our next starting objective, we're continuing to skip around a little bit. So now we have a 2 there, which means we're going back to talking about identities. So these are connected in the fact that they're all identities, but each of these identities videos is a little bit different because we're using a different type of identity. You can see this one we're using even and odd identities. So an identity is an equation that is always true, so it's just we can kind of plug things in. We're just going to keep adding more identities that we can use when we're relating our trig functions together. So at the beginning, I mentioned the words even and odd. So what do those mean? So it actually applies to stuff outside of just the trig functions. You can talk about even functions and odd functions, anything. An even function is one that is the same number when you plug in a negative or a positive number. And the simplest example is x squared. So if I were to graph x squared, it looks like this. And if I plug in this positive number here, I get the same thing if I plug in its negative number, right? So those y values are the same. And the thing we say about even functions is they're symmetric about the y-axis. So if I take this right-hand side of my function and I flip it over the y-axis, I'm going to get the left-hand side and vice versa. All right, notation-wise, an even function, if I plug in a negative value, I get out the same thing as the positive value. All right, so that is an even function. Again, with the word even, just think about x squared. 2 is an even number, and that'll give you this picture of being symmetric about the y-axis. All right, an odd function is similar, except when I plug in a negative number, I'm going to get the negative of the original. So let's look at our kind of basic example again. Odd x cubed is going to be our example because 3 is an odd number. All right, so if you were to graph x cubed, you're going to see the graph looks like this. If I plug in this positive number here, I'm going to get out this number there. If I plug in this negative number, I'm going to get the negative of the y value I had up here. And just to go in the same order as what we talked about in even, we say this one is symmetric about the origin. So if I take this right-hand side and I kind of rotate it around the origin, which is that point right in the middle, if I rotate it around, it's going to become the left-hand side. And notation-wise, an odd function, if I plug in a negative, I'm going to get the negative version as if I plugged in the positive. All right, so these are things you can talk about with a lot of different types of functions, but we'll see how they apply to our trig functions in a second. So even, plugging in a positive and negative is the exact same thing. Odd, plugging in a negative is just a negative of the original. So we'll see how that works in our trig functions. All right, so cosine turns out to be even, which means if I put in a negative value in cosine, I can just make it the positive value and I get the exact same thing. So cosine is really nice. The negative values are just the same as the positive values. All right, sine is odd, which means if I put in a negative, this negative kind of jumps out in front, and then I can just put in the positive number. So this is going to help us do the negative angles a little bit quicker because we don't have to think about which rotation or how we're rotating around the circle. We can just use these properties. So say we want to calculate cosine of negative 150. This is technically something we already know how to do. But sometimes thinking of negative and positive directions, you can mess up the quadrants. But based on the fact that we know that cosine is even, we can say this is just cosine of 150. All right, so cosine of that negative angle is the exact same as the cosine of the positive angle. And cosine of 150 is related to the 30-degree angle. And this is going to give us negative square root 3 over 2. All right, so this last step I've been doing for a while. How do you figure out cosine of 150? I use your reference angle, and it's in quadrant 2, so you get negative. But the important thing is that this first step is the new thing. We can make the problem a little bit simpler by just getting rid of this negative angle. All right, so for yours, go ahead and calculate cosine of negative 60 degrees. And this is what you should come up with. Again, you don't need to use this even on identity, but cosine of negative 60 is the exact same as cosine of 60. And then cosine of 60, we have our kind of unit circle first quadrant. We know that's 1/2. All right, calculate sine of negative 135 degrees. All right, so sine is different than cosine. Sine is not even, it's odd. So sine of negative 135 is going to be the same as negative sine of 135. So with the sine function being odd, this negative sign kind of jumps out to the front and becomes that negative sign there. But then sine of 135, it's related to the 45-degree angle. All right, so the negative is going to stick around. Sine of 135 is the square root of 2 over 2. And our final answer is the negative square root of 2 over 2. So similar to the cosine one, we just have an extra negative sign at the front, all right, the whole time. But it allows us to think about things in terms of positive angles, and knowing this is in quadrant 2, it's a little bit easier when we're using the positive angles. All right, so for our multiple choice question, what is sine of negative 90? All right, you have a lot of different ways you can do this, all right, but try to use the even and odd identities. I just get practice with that. All right, what is sine of negative 90?